So hello everyone, in this video we are going to look at another very easy problems, could be slightly tricky, and the problem statement is to count the number of set bits in a given number. To count the number of set bits in a given number. So let's move on with the description of problem statement and the logic. Count set bits. Set bits. Perfect. Now what? Let's suppose the number given is 5. What is 5? 5 is 0, 1, 0, 1. So answer should be 2. Hmm. What about 7? 7 is what? 0, 1, 1, 1. Answer should be 3. So basically all we have to do is nothing, but we need to count the number of set bits. We need to count the number of set bits in a given number. What is a set bit? Basically if a bit is 1, then it is a set bit. And if a bit is 0, then it is not a set bit. That's it. So that's why two ones, that's why answer is 2. In 7 answer is 3. How to do it? How to do it? Simple, very simple. Let's say our number is 10100, something like this. Now through the logic of odd even numbers, we know how to check this last set bit. We know how to check this last set bit, okay, but we don't have any method to check these other bits. We don't have any method to check this remaining bits, but we can successfully check this last bit whether it is set or not. So in this particular scenario, what we will do is we will simply check for the last bit, and then we will right shift the whole number. So if the number is, so at step 1 we will check if 10100, okay, the number is 0 and initially the count is 0, okay. Step 1 we will check the last bit, okay, it is 0. Then what? Right shift. After right shifting, number would become 01010, something like this. Again check something like this, okay, it is 0, okay, count, no count, plus plus, okay. Then what? Step 3. Okay, so what is step 3? Again right shift by 1, so 00101. Okay, the rightmost bit is 1 now. Okay, so count should be incremented from 0 to 1. Okay, then again right shift. Step 4, 00010. We check this bit. Okay, no count, plus plus, because it is 0. Step 5, 00001. Okay, count incremented to 2. Step 6, right, 00000. Okay, once we get 0, stop. Once we get 0, stop. And how we can check this last bit whether it is set or not? We can check this by using logic of even odd, which we have discussed in our previous videos. So if n and 1 is equal to 1, then the last bit is set and the number is odd. But if n and 1 is equal to 0, then the last bit is 0 and it is not set and the number is even. So we will just keep on checking last bit and right shift in every loop. So we will write the code using while loop. Okay, so I hope the logic is quite clear. I strongly recommend you guys now to please pause this video and continue to write the code on your own, and then just in case if you are stuck somewhere, you can anyways come back and refer. So scanner sc is equal to new scanner system.in. Perfect. Then what? int num is equal to next sc.nextInt, and sout no, count of set bits is count of set bits is count bits function, and we will pass our num as a parameter in this. Now let's write this count bits function. So static int count bits int num perfect. And now what? Now while num is not equal to 0. Okay, but before that int count is equal to 0 we have to set. While num is not equal to 0, if num and 1. Okay, so I think we need to put some extra brackets. If num and 1 is equal to 1, then in this case we will do count plus plus. This means the last digit is 1, that is it is set, and num is equal to num right shift 1. Num is equal to num right shift 1, and this will go on continuing, and at the end we will return count. At the end we will return count. Perfect. And just one thing, we need to do sc dot close to remove this warning. Perfect. Now let's just try to run this. So for number 5, answer should be 2. Count of set bits is 2. Perfect. Let's try for 7. For 7 it should be what? 3. So 7 count of set bits is 3. Perfect. And lastly, let's do something for 64. Count of set bits is 1. There is only one set bit in case of 64. Perfect. So that's all as far as this video is concerned. I think logic is pretty simple. Code is also simple. I hope you are able to develop this logic. And that's all as far as this video is concerned. Thank you for watching till end. If you think I have made any significant contribution in your logic building, please do consider subscribing, and I will see you in the next one. Thank you.